Hello friends, Shimash this side, and today we are going to solve one of the very good questions of JEE Advanced 2016 Chemistry, and this is the one. The beauty of this question is that the in an intermediate reaction, the one reaction is involved, which is like very beautiful and very hard to strike during the exam. And personally, I like this question very much. And to do this question, there are three reactions which you must know, and if you are confident enough that you know it, you may skip next 2 minutes. And if you want to know those reactions, then you can see next 2 minutes as well. So here we are. So the first, like one of the first reaction we require to solve this question is aldol reaction, and basically the basic idea of cross aldol as well. So in that, okay. So in that, if we have a alpha hydrogen, then this H is acidic because its conjugate base would be stable due to resonance. So it is because it is acidic, so it's sensitive to base, and it would react with NaOH to give in all like this kind of ion. So in aldol reactions, so basically name aldol is due to the product which would be formed in this reaction, and aldol condensation is its actual name. So what would happen that if like it's for all the, if it has alpha H in its side atom of the ketone, then it's for all the aldehydes or ketones. So the requirement is that we must have an alpha hydrogen next to, like alpha hydrogen for with respect to the carbonyl group. So we react it with NaOH, and if we are saying that the reaction is happening with only this compound, like we don't have any other compound, then the first step of the reaction is making of an carbanion, because it's a base, it's, and this H is acidic, do like where we said air, we get this, and this carbanion attacks on other member of his type, and this bonds open, and we get a product which is called as aldol, because it has a, like, because this reaction is prominently for aldehydes, because it is involving nucleophilic substitution, nucleophilic addition reaction, and nucleophilic addition are is statically controlled. So if R is H, then this reaction is for aldehyde, and we get something like this, if I am not wrong. mm, I think here would be CS3. Okay, anyways, something we get like this, and this is known as aldol. And if we heat it, then due to this H is pretty acidic again, so on heating, the here carbanion would be formed very easily. This carbanion would push out OH minus, and we would get a conjugated double bond. And if we have some other compound in place of this, like for example we have acetone, which is reacting with formaldehyde in presence of NaOH as a base, then first of all we would take its hydrogen, because we will get a carbanion here, and it would attack on formaldehyde, and formaldehyde is best for nucleophilic addition. So by preference we would choose this one, that we would make carbanion this side, we get carbanion here, COHH, it attacks over there, and this kind of reaction is known as a, like, cross aldol reaction, because it's reacting with some other thing. We get this. And so this is the basic of aldol, and I think we can solve this question from this. The main idea is that the carbanion is formed by a sterically crowded group, and because the formaldehyde has to be attacked as it's good for nucleophilic addition. So it is an idea which would be used in this question as well. Second reaction we would need, like second reaction we would need for this question is Cannizzaro reaction. It is a double displacement, sorry, it is a disproportionation kind of reaction. Let me find a room. It's a disproportionation kind of reaction in which RCRO, but like this, reacts with one of its own kind, and one of them is should be H here also, like its reaction for aldehydes in presence of NaOH. So this reaction happens if R has like no alpha H. If there is no alpha H, then only this reaction happens, and we can see how, why, like let's say this is adjacent carbon, C double bond OH. Now here we don't have like in the previous reaction we're taken out this as H plus, but now we do not have anything, so OH minus would, which is used as catalyst, would come here and attack. We will open this bond, C R R R C O OH here, O minus here, and H. And now we will see a kind of intramolecular hydride shift, sorry, intermolecular hydride shift, because other aldehyde is sitting over there. This bond would come inside, and H minus hydride shift would be there, and this H minus would attack here, and this bond would open, and we would get a alkoxide ion over here, something like this. And over there we would get carboxylic acid. And now this alkoxide ion, which is very more basic than its conjugate base, would attack, and we would get an alcohol and an carboxylate ion, and then carboxylate ion. So this is Cannizzaro reaction, second reaction used in this question. And the third reaction is kind of this, like if I have ROH and I add formaldehyde in it in presence of H plus, then we can see this reaction like this. uh, like formaldehyde is like this, something, H here, H here, H plus would get protonated, and this bond will be electrophilic bond, sorry, this carbon will electrophilic carbon. So the lone pair here over here, this is in reaction, would get a good opportunity to attack over here, and this would open. Here we are getting OH, so it would become R H one of this kind. Okay, and we can also see one more kind of thing over there. If in the R we are like, if R is something R dash OH, because that is also being used in this question, then this would get protonate or that would get protonate, doesn't matter as much. It would attack on this carbon, this H2O out, and we would get a ether. Like this is basic idea of all three reactions which are being used in the question. This one is Cannizzaro reaction, this one is acetal reaction, and alcohol plus alcohol gives ether reaction kind of thing. And this one is aldol reaction, which would be the first step of our question. So now let's directly come to the question. So first I'm up to solving the first reaction scheme of the question, and here it's CHO is an axis. So idea we have seen over there. First of all, we will find an alpha H. We have one alpha H over here, and NaOH would take this alpha H out. We will get an carbanion. This carbanion would attack formaldehyde. This carbanion will attack C double bond OH H. This over here, and this bond would open like this. Same idea as we were using in aldol reaction. If I am not wrong, we are getting something like this. Okay, and here we have to see that like in the two reactions, in the Cannizzaro reaction as well as in that reaction, OH minus is catalyst, so it's duty of the system to return the catalyst back, and that would be returned in form of H2O. Like in the system we of course have H2O as well, because we when we did this step we would have got H2O, OH minus H plus. Now this H2O is kind of HOH. H plus would be taken by this and OH minus out. We will get beta hydroxy aldehyde, and this is aldol. Now it has given to heat as well. So on heating this compound, we won't get much, because like the thing we were doing over there is one H over here. So we are making a carbanion and we are making it out, but here is no H. There is no H over here, so nothing can be done in this respect. But this reaction is not yet over. We have a ketone over here, and we have HCHO in axis and NaOH as well. And yes, we will do Cannizzaro reaction one more time. Like second time this compound would react. And first time for Cannizzaro reaction. In Cannizzaro reaction, we first of all attack NaOH OH in one, which is statically less hindered, or which is very prone to nucleophilic addition, and which is of course formaldehyde due to steric hindrance. Over here we get O minus OH. I'm feeling pretty sleepy because the time is this in the morning and I haven't slept in this night. I haven't slept this night. So this is the thing we are getting, and this bond in H minus out. This H minus would attack over here. This bond opens and we get, so you may see this thing, and we get what I have drawn in name of benzene. O minus this OH, and again in the same way this is alkoxide ion, this is carboxylic acid. Our carboxylic acid is more acidic, so H plus goes over here and we get a diol. This is the same thing we have got over here. Now I'm in the second step of the reaction. I think first step is complete because now no further NaOH and HCOH can react. Now we are reacting with this species with formaldehyde in H plus, and formaldehyde is limited in catalytic amount. So HCOH in the same way. First of all, protonation. This would attack, and preferably this would attack because oxygen here is supported by plus m effect of benzene kind of thing. Anyways, it doesn't matter because there is nothing of isotopic effect, so you may do anything, and we get mm, I don't know what I'm drawing. I need to do it properly. Like basically, I have to visualize this attack. This OH minus go over here. This bond would open. Yeah, like C here and OH over here. We can also visualize like this. I think it's easier. And I don't like drawing H's in these questions. So please forgive me for this sin. Okay, now the question isn't finished yet because we still have H plus. We still have H plus and HCHO as well. Now HCHO can't do much great things, but this H plus would protonate one of them. Let's say this one or this one. Like carbocation form must be more stable. Like here we would have 2 alpha H if carbocation is found over here, then a plus M effect, not 2 alpha H. I told you like I'm in a sleepy mood. So this would be protoned to make a stable carbocation over there. O C O H plus H. This, and this. Now here oxygen has a lone pair. This lone pair will attack over here, and this H2O is out, and we finally get this kind of species. And yes, this is the answer. And you may check from the answer key, the answer is this only. So this question involved 4 steps. If I try to summarize in front of you, the first step was the aldol reaction, in which in presence of NaOH and formaldehyde we got something, a compound like this. Then it underwent Canizaro's reaction, in which this compound became something like this, OH. No, what I'm saying. Mm. Yes, this is of okay. So in the reaction scheme, first was this one, and in second, this is the case. Formaldehyde and H plus reacts with it, and it isn't traces. In like only one time reaction allowed, and the one time reaction would do acetyl formation reaction, in which we would get this thing, and we would get this thing. Then it would be protonated, so we are getting a good carbocation. And OCOH, here OH. Oh, what I've done, like this is not connected to benzene. Okay, OCOH. Oh, hmm, I'm very bad at drawing and all these things. Okay, I've got this thing. This is the solid boundary. Now protonation would, this here carbocation would be created. OC plus, and over here this kind of thing. Now here we have this would attack over here, and H plus would be out as we have taken it as catalyst, and we get this species again. So this is it for this video. Thanks for watching. Please like the video and comment if I've committed some mistake, and please subscribe my channel, Shivansh Gupta. Thanks for watching.